But continuous integration is one of these that I think we can make up a little bit of time in. So what is continuous integration? First, I'm going to go over just the definitions and how it's used inside of your workflow, and I'll end with nuts and bolts of starting out a continuous integration workflow for yourself. Continuous integration is just this process of inserting something, inserting a check or running of the tests in between in your development cycle. You've created a new branch, you've added a couple of code changes, and you've pushed them to the repository. Continuous integration can test those before you're allowed to merge them, or it can test them before you decide to merge them into your main development branch. And that actually helps you a lot, so that you know, as a final check on your code, that what's been sent up to the server is actually not going to break the build. Continuous deployment is something that happens over here after you've merged your code and you decide to make a deployment. That's covered at the very end. Continuous integration testing is focused on testing the critical infrastructure. Should be tests, a lot of tests that are fast running and that are kind of independent and orthogonal to each other, and that allow you to completely test your source code. Existing test suites often require you to redesign or refactor for CI because, again, existing test suites probably have a mix of fast running tests and slow running tests. And when you continuous integration is integrated into your workflow, which is another difference between what people are sometimes doing that's not an integrated workflow with testing. So if you develop a whole lot, then you merge it into the build and then you test it. Here, these tests can come up with errors and you're stuck, starting all over again and looking at all this development that you did. But if you're continuously testing these, if you're developing and merging and testing often, then the idea is that these small changes can each be tested as they're integrated into the build, which takes a little bit of time to run the tests. But again, if they're fast running, should save you the time of going backwards and figuring out what happened. Plus, if you're having multiple developers work at the same time, merging often is helpful for everyone. CI implies generally a lot of automation. So you could do this on your own without a CI system, and then it would be automated testing, or it would be some sort of automated testing. But this automation is key so that you're not having to manually do computer forensics every time you want to merge some code. There are several systems that provide auto testing, and we've talked about a lot of those. These automated tests could possibly live next to your development workflow and might not necessarily be integrated. Continuous integration is specifically for things that are actually integrated in. So things like GitHub, where it's tested, and I'll show you some other places these are integrated. Here again, nightly testing dashboard could live next to your development work and could give you reports on code coverage, what's being tested on a night-by-night basis for very long-running tests. CI is embedded in your development work. And you can usually get, for GitHub, you can actually see status of your tests as you're putting pull requests in. CI is actually not a miracle. It's not completely miraculous because there are some situations that make CI difficult. Just getting started means you have to navigate a little bit of your technology choices. You also have to think about putting some of your workflow in the cloud, which I think we've seen questions about that. What do you do with large files? What do you do if you don't necessarily want to trust external places with your source code? And so there can be a startup cost. Developing suitable tests that work with CI is not it's not always intuitive and obvious. So you have to refactor. You might have to refactor your test suite a little bit, and it's also important that when you're testing, you provide sufficient test coverage so that you don't have a false sense of security that you have a big green check mark inside of GitHub, so you feel like your code is fine, where maybe there was an important test case that you didn't include in CI because it was too long running. So you should be aware that there's some pitfalls to it as well. Also, making a test that is a little bit too rigorous with a code can prevent people from being able to merge, and that happens sometimes. And is a source of unhappiness for all of the developers when the test suite is preventing you from merging something that is legitimately okay, and now you're stuck going and figuring out what's wrong with your test suite. What does CI look like in practice? I mentioned that there's a lot of places and ways that you can run CI. In this tutorial, I'm going to focus on just the free GitHub Workflows option, but you should be aware that there's Travis CI, Circle CI, Azure pipelines for Microsoft Cloud. You can also implement CI with GitLab. These launch on virtual machines, which are constrained in the amount of runtime that they have and how large, how much size, how much memory they can take up on the virtual machine. You also might not be able to find the latest hardware. GitHub lets you do some tests on GPUs, but I believe they're more expensive. I don't know if they'll allow you to, obviously they're not going to allow you to run on the latest, most expensive hardware because they're just not going to make that available for everyone. You might have site local resources that are worth looking into, and you should check your own site for information on those. What it looks like from a perspective of, so I've showed you the development cycle where you make a new branch and you make some commits and you send it off, and you send it off to GitHub and it runs a test. What's actually happening is GitHub is contacting either an internal service if it's GitHub Workflows, or it's contacting the external service, Travis CI if it's Travis, and it's sending them a notification that your code's been changed. This service will pull a copy and do all the build steps and return its results to GitHub so that you can view them in the web viewer. You might also have code coverage set up, in which case GitHub notifies CodeCov that you have a new change to your source code, and CodeCov can provide you something that you can view directly, or it could send some information to GitHub for you to view there. If you are to use a GitLab server that's installed locally, then those local GitLab servers might be equipped with their own GitLab runners, which will do something similar. So you do a code commit, the GitLab runner will execute and put its results up here. So it involves a lot of external services that are outside of you, and not necessarily the easiest things to control, right? If you're setting up a multi-party build test pipeline, then you have to have accounts on each one of these systems, and they have to know each other and be linked correctly, and all that's extra infrastructure. In practice, it's not that hard to do, and it's in our walkthrough. So if you really want to, if you do this for the first time, I definitely recommend that you go through the examples in our hands-on materials. Just like designing tests, you have to design how you're going to build your CI pipeline. So the kind of questions you want to ask are, which configurations are the most important ones to test? Do you want to test with different versions of MPI? Is it important that your Python code is cross-compatible between 2 and 3? Which compilers are you going to use? What functionality do you want to test? Are you doing just vanilla numerical kernels, or are they special OpenMP or GPU? These actually define the kind of set the level of difficulty in being able to set up your CI pipeline. Good candidates when you're just getting started are to create a hello world example for your project and then just add to it. At a minimum, even just building your project code is a great place to start, because it tells you if there's a syntax error that prevents your build. And you can even test a couple of different build systems or operating systems. And obviously, you can look at dependencies of your code. And it forces you to think through and put in. Probably you've had the experience by now of trying to work with an external code and realizing that it's difficult to build that external code. But if they have a continuous integration workflow set up, you can have the aha moment where you realize all the dependencies and instructions on how to run that code are directly there inside of their CI configuration file. So if you follow that, you can set up your system the same way their CI tests are run. So CI also lets you kind of document that dependency process. To get started with CI, as I mentioned, there's a lot of providers. I'm going to talk about the GitHub Actions way. And with GitHub Actions, there's a little button that's right here at the top of your GitHub repository that's Actions. And if you don't have this enabled yet on your repository, you'll get a nice getting started page, which walks you through the steps. You can pull a you can pull a template like C and C++ with make. This is the template that you would use for our Hello World example. And what that template will do is it'll create a .github/workflows testname.yaml file inside of your repository. So this is another key thing, that it's good to keep your documentation and your tests and your CI files, if possible, all inside your same development repository, so that as you change things in development with your source code, you're also keeping your documentation and your workflows up to date in the same place. What is inside the GitHub Actions file? It's nothing very complicated. There's a nice name that you can repeat to yourself on their web pages. What actions will trigger the run of this workflow? So the default is to run it every time you push to your branches and every time there's a pull request. Note that running it on a pull request means that people who are able to put pull requests on your repository can trigger your CI actions. External collaborators who just decide to fork your code and provide something will trigger CI, and you might run into runtime limits if your CI is running too long. But usually it's good to know if the external code commits pass, or external pull requests are passing CI or not. Jobs are telling GitHub CI exactly what steps to run. So build would be like the step 1, and here's the build job, which is going to run multiple steps. Actions, I don't have time to get into too much on what actions are available. Just know that these are documented inside of GitHub, and probably the action that you're most interested in is just checking out your code. And then direct run scripts, which are running commands. So these are the make commands that I would have executed directly at the command line were I testing it myself, but I can type these into a script. And now that I've typed them into a script, the CI will do them for me on the cloud inside of a container. All right, what does it look like after you commit some code, send it out to the repository, and the action fires? You should see now under the Actions tab that that each code commit has a run for that action, which tells you what steps ran for the action, and it also tells you the output results from those. Over here on the right, if you've enabled codecov.io, then that codecov will also give you the nice, this is a picture of the summary that codecov will give you for your coverage. It looks like crank-n wasn't tested, it wasn't covered. So if you want to get your feet wet, you can go in and find a way to make sure that this file is exercised during your tests by modifying your tests. After you've done this for a while, you'll have the accumulated results of tests on old versions of your code. GitHub keeps these things around for several days, so it's nice to see that the history of what worked and what didn't work. Green is check everything worked. This red is obviously there was an error somewhere inside of the build, and sometimes you can also see an orange in progress because the build is still happening. If your CI runs take too long or they require downloading too many external dependencies, then you could get very long wait times, and sometimes those waits could get stuck, and you might have to go in and manage the screen a lot. So it's important to have a CI that's as tightly defined as possible. So I just talked about status indicators. When you're designing your tests, I've already talked about some of these key elements on what's running. There is actually a way to design your tests so that you test multiple different configurations of your code. So this build job might be templated with a target that comes from these different OSs. It might have a Python version, and it might also have an other. Here, others not being used. But if you set up your test this way on GitLab, what will happen is this build step will run for every combination in this matrix. And so you'll be testing Python 3.8 and 3.9 on each one of these platforms. And this can be nice to be sure that you're not coding to something that's Python 3.6 specific and has been deprecated and removed in Python 3.9. Again, these are the same kind of command line type tests. It's just there's an extra strategy. And so the next slide will actually show you that the steps that happen inside of that templated build are the same. You can get really fancy with these scripts if you want to, and you can include the templates inside of your script. this run colon and then a pipe here. This is a YAML syntax shortcut. There's some really good primers out there on YAML syntax, which will tell you how to use some of the cool features of YAML in order to write these files so that you can take advantage of making this giant blob as one single string. What's important to keep in mind with YAML is that it's indentation sensitive. Colons define a key value pairing, and dashes define list elements. So steps is a key with a list as its values. Name is a key with configure job parameters as a string value. Run is a key with this giant thing as a string value. All right, there's ways you can go farther with continuous integration, where of course you're doing an inner loop with coding, testing, running, debugging, and committing. That goes to your code repo and does some CI. This is the outer loop where things actually go outside of your local control. And the more you can make this inner loop like your outer loop, the better experience you'll have with CI. So running your tests locally before contributing them is going to help. You can investigate lots of ways to go farther with CI. And finally, there's an automated release process. I want to check on my time here. Okay, so I'm running out of time. But with release automation, there are ways to create CI-like jobs with commands that are doing a release. And the way that happens is they just have extra environment variables that give them the ability to do the authentication with the release process. Let's see. So I'll let you guys go and read on release automation a little bit farther if you want to. It's something that helps you if you create a tag, you can push the tag to GitHub, and then if you've created the release automation YAML script, then GitHub will see that you've created a new tag, and it will create a release that's a tarball release that's dropped into the GitHub releases section. And you can add tests for that as well. There are lots of alternatives. This is a Travis CI file, which accomplishes the same thing that I showed you from the GitHub CI file. And it's just that the syntax is a little bit different. So in summary, you want to start simple to get automation working. And then there's a lot that you can do. There are free services that are a great place to start. But the CI is complementing it and not replacing more extensive scheduled tests.